Good afternoon students, and welcome to another video. So in this video we are going to study another method that uses the quicksort algorithm. So it is actually another technique that uses the divide and conquer strategy. So one of the techniques that we studied earlier involved merge sorting. So we already know what merge sort is. If you have not seen that video where merge sort is explained in details, I'd suggest you go ahead and watch it right now. Once you've understood merge sort, you can continue learning more about the divide and conquer strategy and then begin the process of learning quicksort algorithm. So let us see what does it say about quicksort over here. So it is an efficient in place comparison based divide and conquer sorting algorithm. So it is an efficient algorithm because like merge sort, the complexity of quicksort is also n log n into log n, that is comparison based and in place. In place means, say when you are sorting an array, whatever sorting process, whatever space the process of sorting requires is confined to that array only. Okay, so you don't need any additional space apart from the space that is already available in the array. So algorithms like quicksort, which fulfill this criteria, which do not require any additional space apart from the one that is already at its disposal, is called quicksort. And it is also said to be a comparison based algorithm. That means it is comparing between the elements and then it is swapping their positions. So it also uses comparison, and it is a divide and conquer algorithm that is already known to us. So it is widely used because of its average case performance and minimal memory usage. Okay, now let us go to the next slide. What are the steps in quicksort? So steps in quicksort involve, first of all, the most important step. It involves selecting an element as the pivot. Pivot means before you are splitting the array into two halves, one of the half will have a set of numbers which will be less than the pivot, and another half will have some numbers which are bigger than the pivot. So the pivot element needs to be selected properly. Usually it is a good idea to select a middle element, middle value. So out of all the values that you are having, it is a good idea to select a value at the middle of the array. That means an intermediate value as the pivot. So this thing should be kept in mind while selecting a pivot element. Now after selection of the pivot is done, we are going to partition the array into two halves. Rearrange elements so that all the smaller elements go to the left half and larger to the right. That I have already told you. Now in all of these two halves, we are going to recursively apply the quicksort procedure and sort the subarrays until we get the desired results. Let us see an example of quicksort. So here you can see there is an initial array comprising of some numbers. Say there are 5 numbers. So in this array we are having some numbers that you can see from 0 to 4. So there are 5 elements in total. Out of that we are selecting as the pivot element the number 29. So 29 is selected because it is an intermediate value. Out of all the values that are available here, 29 is the intermediate value. Now we are partitioning the elements into two halves. The first partition on the left comprises of some numbers which are less than 29, and at the right there is another number which is bigger than 29. Now we are going to sort the left partition. So the left partition had 10, 14 and 13. So here also we are going to recursively apply the quicksort algorithm. So here we are selecting 10 as the pivot. And so 10, after selecting 10 we are getting two halves, one only has 10, the other one has 14 and 13. Okay, after getting the two halves, 10 in the array containing of only one element 10, it is no longer needed to perform any further steps of sorting. But in the right array there are two numbers, so we are going to have to apply quick sort once again. So after selecting 14 as pivot, we are getting two more numbers, that is 13 and 14. Next we are going to combine these two partitions and select and get a larger array. So after splitting the array into two halves, we are getting some numbers, and then we are going to sort them and combine them. So combining the partitions 10, 13, 14, 37 with 29 in the middle. So we are finally getting the sorted array. So these are the steps in which you can solve quick sort. So what are the advantages of quick sort? Advantages are its average case has a complexity of n log n. So this is quite fast, and n log n means it is also very efficient. It is an in-place sort, that means, as I have already mentioned earlier, that it does not require any more space apart from the space that is already allocated to it in the array, and it is very efficient for large data sets because it does not require too much space and has a complexity of n log n. It is efficient. Okay, so advantage of quick sort: fast average case performance, O(n) log n, and it is an in-place sort, that means it requires no additional space in the memory, and it is efficient for large data sets. Disadvantage of quick sort: poor worst case performance. If you are selecting a pivot that is not an intermediate value, that is either too high or too low, then that means the division of the array into two halves will not be in a proper way, and that means selection of numbers will be poor. So in that case the performance will be O(n) square, that means you will have to compare each of the numbers twice or maybe more than twice, and it is said to be an unstable algorithm. Unstable means when you are sorting an array that comprises of, say, a particular number repeatedly, a stable algorithm while sorting will preserve the relative position of those numbers. Merge sort is a stable algorithm because when you are sorting an array, suppose in an array the number 7 occurs in 3 places, say at 2, 5 and 6. So even after the sorting is completed, you will see that those positions are intact, that has not been altered in case of merge sort, but for quick sort those positions will be altered. Next is recursive depth. That means if you have to divide the array into several halves repeatedly, you will have to make several recursive calls. So it will be, the depth of recursion will be very high. Quick sort's complexity analysis: best case is O(n) log n, average case is O(n) log n, best and average case is O(n) log n. So this is ideal for sorting large data sets. Worst case is O(n) square. O(n) square means it is sorting an array several times, so it is subdividing the array and sorting it several times, so it is the worst case. And space complexity is O log n. So what are the criteria that one should keep in mind for selecting a good pivot? Random pivot, that means selecting any random number, though that is not recommended. So it is better to select the median of the three, as is outlined in the next point. So you should select an intermediate value which is around the average of first, middle and last elements. So in that way you can divide the array into two equal halves. Next is hybrid algorithm. So it is this thing intro sort. This is outside the scope of our current discussion, so we are not going into any more details about it. So the two things that you should keep in mind is either you can select a number randomly. In random selection there is a less chance of selecting either a value that is too high or too low, unless you are too unlucky, or ideally you should select an average or a middle value. That means a number that occurs in the middle. So it will let you divide the array into two halves, and in two halves you will get a good quantity of numbers. So in conclusion, we can say that it is one of the fastest sorting algorithms for average use, because the best case and average case is both n log n. And proper pivot selection is the ideal. It is actually the key factor which decides whether you are sorting the array efficiently or inefficiently. Pivot selection should be done very carefully, otherwise you will get some issues. And you can use it in several programming libraries and real world applications. So that concludes our tutorial on quicksort, and I'll see you in my next video.